As we said, there are three Newton laws of motion, and these are the first law of motion, the second law of motion, and the third law of motion. The first law of motion is about the state of rest or state of uniform or the state of motion of an object. So we say that the first Newton law of motion states that an object remains in a state of motion or in a state of rest or of uniform motion in a straight line unless compelled to act otherwise by some external force. There are other two laws, Newton laws of motion, and there is the law of conservation of the linear momentum. But the second law states that force, it's about force, it states that force applied is directly related or indirectly proportional to rate of change of momentum and takes place in the direction of the force. That law of motion is about action and reaction forces are opposite and equal. State if bond A exerts a force on bond B, then bond B exerts equal and opposite force to bond A. That is about the action and reaction forces. They are opposite and equal, and they are a pair of parallel forces that act along the same plane. Now, let us talk about let us discuss the second equation. That is about, we are told to define the term inertia. Where does inertia come from? First of all, we get that from the first law of motion, that unbounded motion will always unbounded will always remain in a state of motion unless an external force acts so that it changes its nature of motion. So in this case, we say that the term inertia is found about the first Newton law of motion, and it states that it's a term that is used to define the tendency of unbounded to resist a change in its state of motion. So that is the tendency of unbounded to resist change in its state of motion, that is, or of rest. So for example, when you start a vehicle, you realize that the passengers will jerk forward and back, will lean backward towards the seat. That means that they are trying to resist the change in their state of motion. So that is, they want to still remain at rest, but you have started the vehicle, so you have changed the state of motion, but the body is resisting the change in it. Now, we have the other question, that is question number 3, and you are told a 2 kilogram mass body is traveling in a straight line with a velocity of 3 meters per second. That is 3 meters per second. A force F acts on the mass for 5 seconds. So you are told that a force F acts on the mass for 5 seconds in the direction in which it is traveling. So the question is, if the velocity increases to 8 meters per second, calculate the initial momentum. So this is pertaining the second law, the second Newton law of motion, and that's why you realize that you have force is equal to mv minus mu over t. That is, you are told that force is directly proportional to the rate of change of momentum. The rate of change of momentum is mv minus mu over t, and takes place in the direction of the force applied. So you have F is equal to mv minus mu over t. That is, first of all, we have the mass of the body is 2 kilograms, and we have also the velocity of the body is 3 meters per second. What else do we have? We also have the time in which the force acts on the body is 5 seconds. And we also have that the final velocity, that is the initial velocity u, is 3 meters per second. Now the final velocity is 8 meters per second. So to calculate the initial momentum, obvious, we know that the initial momentum should be mu. That is initial momentum of the body. So mu, it means we have to multiply the mass, that is 2 kilograms, multiplied with the velocity, that is 3 meters per second, the initial velocity. So you realize that the initial momentum should be 2 times 3, that is 6 kilogram meter per second. That is the initial momentum. Then the final momentum, that is mv, which is final momentum. Final momentum is calculated by multiplying the mass times the final velocity. That is the mass, which is 2 kilograms, times the final velocity, which is 8 meters per second. That is 2 times 8, you get 16 kilogram meter per second. This is the final momentum, and now you are asked calculate the magnitude of F, force F, and we know that this is the second Newton law of motion, which is F is equal to mv minus mu over t. That is, F is equal to, we have mv, that is the final velocity, which is 16, minus initial velocity, which is 6, over t, time, that is time was 5 seconds. So you realize that this is 16 minus 6, get that one is 10 over 5. First, 10 divided by 5, you realize that is 2, that is kilogram per meter second divided by second. This is 2 kilogram meter per second square. That is a force. This is like you can say that this is like 2 newtons. That is the force, the rate of change of momentum. So that is question number 3. And then we have the question number 4. This is the question number 4. Derive the formula of half mv squared. Ke is equal to half mv squared. And you realize that this is a formula for calculating the kinetic energy of a body. So the kinetic energy Ke is equal to half mv squared. How do we arrive at this formula? This is what you do. First of all, the energy. What is energy? Energy is the ability of a body to do work. That is it. And now, from our definition of what is energy, we know that your ability to do work is equal to the work that is done that is it. So you can say that energy is equal to work done. It is the same, it is equivalent. It's equivalent to work done. Therefore, we know that Ke, which is kinetic energy, is the energy that is possessed by a body due to its state of motion. Therefore, kinetic energy there is equal to work done, which is equal to force times distance. Now, we have force is equal to mass times acceleration A, now times distance, that is the work done. If we have that we have this acceleration, that is we have mass times acceleration. Acceleration in this case should be A, that is half mv squared. This derive the formula half mv squared. So we have this one is equal to that is it acceleration? No, it is velocity, rate of change of velocity, v over t times distance. So this is kinetic energy should be m times v times d over t. So we have Ke, kinetic energy, Ke is equal to now mv d, that is mass times velocity times distance it has traveled over time taken. Now we have change in velocity over time. Change in velocity over time this is v minus u over t. Therefore we have mass mv, and then to get first of all the average velocity, we can say v plus u over 2, so that we can get the average velocity. Therefore in this case we can change this one into v plus u over 2. That is we get Ke, kinetic energy, is equal to m v plus u over 2 times d. That is, you realize that you have mv minus mu over 2 times the distance, so that you can get plus mu times the distance, so that you can get the kinetic energy. And in case whereby, for example, we have that is for a distance of 1 meter, or for every 1 meter distance, you realize that we have the kinetic energy as a constant, that is m, and v, we assume that there is no, therefore, initial or final velocity. It's a uniform velocity, therefore, the first v should be the same, and we have 2 there. Therefore we have half, then m alafu we have v squared, v times v. So that is the formula for calculation of kinetic energy. So let us leave this one at that point. And then we have question number 5.